Okay, so this is the last section of the course, so like I said before, and we'll probably finish this up tomorrow. Probably we'll finish it tomorrow. Well, not today, there's no way. And then next week, from Tuesday to Thursday, we'll have exam 6, which will be 11:6 to 11:10, those 5 sections. And then after that, we'll be studying for the final exam, which will cover all the sections that we covered in the semester, except for haven't decided yet. But I'm probably going to throw some stuff out, just a few sections. But it's going to be it's going to cover almost everything. The exam will be, the final will be over almost everything we cover in the course. Okay, so let's go ahead and get started with the Taylor and Maclaurin series. And okay, so if you have a function f, and you're able to represent that function with a series, with a power series, then the power series is called the Taylor series of the function expanded about a. Okay, and if a is equal to 0, it is the Maclaurin series. So the Maclaurin series is just like it's just a special case of the Taylor series. So it's still a Taylor series if a equals 0, but it's also, it's just referred to as the Maclaurin series. Okay, so now, so look at this equation here. You have f of x equals c0 plus c1 times x minus a plus c2 times x minus a squared and c3 x minus a cubed and so on. Okay, so can anybody tell me really quickly what c0 is going to be in terms of f? What value of, okay, so let me give you a hint. What value of x, what value, what would be a nice value to set x equal to?
0.
That's actually the second nicest value. There's the one that's a lot nicer though.
1.
Equal to. No, 1 is, no. Okay, right here. What would you like to set x equal to right here? A, right?
What?
Okay. And what happens if x is a? What happens to this?
Goes to 0.
Yeah, what happens to this? That's 0 squared, which is also 0, right? Everything's 0. And then
What? Hi, everyone.
C0. So that means that C0 is just f of 0. Whoop. Yep. Okay. So yeah, so this guy right here is just going to be f of 0. Okay, now C1. So that means, so what do you have now? We have f of x equals f of 0 plus, in fact, we don't even need to do that. We know that's f of 0, but we'll just write it as C0. Okay, now, how do you get C1? Yeah, this is more tricky. Like C0 is like you're going up against this mafia and you just took out one of the underlings. Now you're taking out like a C1, that's like a minor boss or something. I'm like somebody that's a little bit higher up in the organization. How do you get them? How do you get that guy? How do you even find him? Okay, this requires some like a little bit of detective work here. So Anybody have any ideas? Because if you set x equal to a, then you can't just, it doesn't work. But there's something you can do before you set x equal to a that that gets rid of this and gets rid of this. And this should have C1 exposed right there. It leaves C1 exposed. It gets rid of that, it gets rid of that, and it leaves C1 exposed. What operation does that?
You derive it? No.
Yes, the derivative. So if you take the derivative of both sides of the equation, then the left-hand side is going to be f prime of x. That's 0. This is, the derivative of this is 1, right? So that's just going to be C1. And then the derivative of this is 2, C2 times x minus a. And then this one's going to be 3, C3 times x minus a squared, and so on. And x is going to be 4, C4, x minus a the third, and so on. Okay, and then now, if you set x equal to a, you get f prime of a. Wait a second, I made a mistake here. This is f of a. I apologize. That's f of a right there. Okay, so f prime of a equals C1. And this is gone, and that's gone, and everything else is gone. So you just get that. So C1 is the first derivative of f at a. Okay, now how about C2? Okay, so for C2, if you take this guy and you take another derivative, you have the second derivative of x, right? And that goes away. And this one, you just left with 2 C2. And then here you have 3 times 2 C3 times x minus a. And then the next one's going to be 4 times 3 C4 x minus a squared, and so on, right? The next one's going to be 5 times 4, next time 6 times 5, and so on. And then if you set x equal to a, you get the second derivative at a is equal to 2 C2. So that means C2 is equal to the second derivative of a divided by 2. Ooh. And what is C3 going to be? Can you guys see the future? And see, what's C3 going to be? So let's see the pattern.
Prime of a over 6.
F triple prime of a over 6. Yeah, that's right, it is 3 times 2. What about Cn? That's going to be the nth derivative. That means nth derivative at a. Divided by
N times n minus 1.
Times n minus 2, all the way down to 2, right? And then 1. So it's n factorial. Okay, so that right there is one way. That's another way to find, that's one way to find, that's the way that they're showing us right here. How to find the terms, how to find these c sub n's. If you have the function, how to find these terms. Now, we already learned another way. We learned the other way last section, where we are just manipulating around the geometric series, 1 over 1 minus x. We're just manipulating that around and doing variations of that. But this is a more direct way that you can use. Okay, so that's the formula for that. Okay, so that's one way you can find the terms. So let's get to the homework. Did we get to the homework? Yeah, there's one right there. And then I've written the formula down because I want to be nice to you guys.
Thank you.
Sure, you're welcome. Okay, now suppose that, so number one, it says find the Maclaurin series. And Maclaurin means that this A is equal to 0. Okay, so that's why there's a 0 there. Okay, so they want us to find the Maclaurin series. And again, it's going to be Cn x to the n is what the Maclaurin series is going to be. Okay, but in this case, if the nth derivative of f at 0 is n plus 1 factorial, then what's Cn going to be? Well, that's going to be just applying this formula here. It's going to be n plus 1 factorial over n factorial. Okay, what's that? What's n plus 1 factorial over n factorial?
N plus 1.
Yeah, that's just n plus 1, okay? Because this is n plus 1 times n minus 1 times so on, down, 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 down. And this is n times n minus 1 times so on. And then all of that cancels with all of that, and we're just left with n plus 1. Okay, and so then that's our Cn. You just put that in there, and so the answer would be n plus 1 times x to the n. Okay, let's go ahead and put that in there and see if that's the answer. So n plus 1 times x to the n. And what's the radius of convergence?
One.
Yes, that's just going to be 1. It's just going to be 1.
That was a good guess.
Because it was a guess. I thought you knew what you were talking about. It sounded like. Okay, so this guy right here, this right here, the n plus 1 is just P series stuff, right? So that doesn't really change the radius of convergence. So you're just looking at this, which if you do like the ratio test, you're gonna get 1. Okay, number 2. Whoa. Use the definition of Taylor series to find the first 4 non-zero terms of this series centered at the given value of A. Okay, so typically, here's what you do. You can make a chart like this. You have n making a table. And I want to find the first 4 non-zero terms. Dang. So I'll go 0, 1, 2, 3. That's 4 terms right there. I'm gonna have to go more if they're not 0. Okay, so now what I want is the nth derivative of x, okay, right here. I'll leave myself a lot of space because this is the function that we're dealing with, right? And then I want the nth derivative evaluated at 0 because it's the Maclaurin series. And then I want this guy right here, the nth derivative evaluated at 0 divided by n factorial, because that's what our terms are going to be. And I want to find the first 4 of these that are not 0. Okay, so the first one is just the original function, like that, which I'll write like that. If you plug a 0 in, you get 5. So its cosine of 0 is 1. So, and then 5 divided by 0 factorial, that's just going to be 5. 0 factorial is 1. Okay. So we basically found the first term, which is 5. So that's going to be the first answer. Yay, we just have 3 more to go. Okay, so now first derivative. Take the derivative of this, and that's going to be, you're going to have a 2 come down, so that's 10 times cosine x times the derivative of cosine, which is negative sine. It's right there. And you put a 0 in here, unfortunately, sine makes the whole thing 0, so that's just 0. So that's no good. Oh, useless. Okay, that means you have to go another term. Okay, that's okay though. Okay, now take a derivative of this, and we have the derivative of cosine, which is negative sine. So that's going to be plus 10 sine x squared plus this part times the derivative of the second part, which is going to be cosine x squared. Okay. Now, if you plug in a 10, no, you plug in a 0 for x, that's going to be a 0. This is going to be 1. So you have a negative 10. And then you take that negative 10 and you divide it by n factorial. That's 2 factorial. So that's negative 5. Okay, since n was 2, then this is negative 5 x squared. Okay, now the next one, the third one, you take the derivative of this. That's going to be 20 sine x cosine x. And then the derivative of this is going to be, I got a 2 come down, so that's 20. Oh. Well, that's interesting. So that's going to be 40 sine x cosine x, right? And then when you plug in the 0, that's just going to be 0. Okay, so let's see here. I can just change one of these to a 40 and knock that one out, basically. Okay, so there's like a pattern here. Looks like you're going to jump back and forth between this and something else. Okay, now the next derivative, that's going to be
Positive 40.
negative 40 sine x squared plus 40 cosine x squared. And so you plug that in, it's going to be positive 40, right? So this will be 40 over 4 factorial. Boo. Five-thirds. Actually, the fourth is going to be the term. Okay, and looks like we'll need 2 more terms because this next one's going to be 0, but we have to calculate it anyway. So you take the derivative of this, and you're going to get
80 cosine sine, negative 80 cosine sine.
negative 160, you mean?
Oh, yeah, that one.
And that's going to be 0. And then the next one is going to be (160 sine squared) minus 160 cosine squared. And then, so that's going to give you negative 160. Wait a minute.
That should be right.
Okay. So negative 160 over 6 factorial. Ooh. This is painful. 6 times 5 times 4 times 3 times 2. Okay, so let's see. The 4 reduces that to a negative 40. And then this 2 reduces it to a negative 20. Oh, wait, there's a 5 reduces it to a negative 4. And this one goes to negative 2. So we have negative 2 over 9, x to the 6th. Okay, so let's put those terms in right here and see if that, and see if WebAssign complains about it. They'll be like, your work is bad. I'm not paying you. Okay, so first 4 non-zero terms. Put those in with commas between them.
Whoa! I got it right.
Yes, I got it right too.
Wait, so which ones do you plug in? The F sub n zeros or, oh, those ones?
These, the terms.
Whoa, okay, hold on.
So the term, you just add the x value, right?
Mm-hmm.
And then the
Yeah,
f,
so from,
and then f to the n of 0, like the column before it, that's like just the value. You'll never have
yeah,
like
that's just fn of 0, yeah.
When do you know how to stop? Like when to stop when you do the terms?
The problem said the first 4 non-zero terms.
First 4.
So, yeah, so these are 0. That's 0, that's 0. 1 and 3 and 5 were zeros. Yeah, those are 0 terms. Because, but this one is negative. These are non-zero. These numbers here. Yeah. If you were to, so basically what it's saying is that this 5 cosine squared x is equal to 5 minus 5 x squared plus 5/3 x to the 4th minus 2/9 x to the 6th. And then if we were to like keep going, this would actually be equal to each other. And this one actually has, it's not clear from this at all, but the radius of convergence is actually infinity. This actually holds for all. As long as you have to go out far enough though, because if x is large, then you're going to be really off. But if you're close to 0, if you're close to this point here, 0, then this is going to be pretty close to what it actually is. Okay, and then if you go more terms, you start approximating it better and better and better. Okay. So that's one way to calculate the Taylor series. And I think that we have to do another problem like that. Let's take e to the negative 6x. Let's see. Here they're actually asking us for the radius of convergence. Okay, so find the Maclaurin series for this using the definition of Maclaurin series. Okay, so now here what we have to do here is we have to find the whole series. You have to find the whole thing. So what you have to try to do is so what we would try to do here in this case is try to figure out what is the pattern, okay? And if we were trying to figure out a pattern with this problem right here, then what we would probably do is go with these right here, because I think you can see there's a pattern here, right? I think you can see there's a pattern here, right? So this is 5 and then -10. And then each of these, it's multiplied by -4 to get the next one for the numerator. And then the denominators are going 2 factorial, 4 factorial, 6 factorial, right? So you can see a pattern there. But if we look at these numbers, then there's like, what is the pattern? And this is really confusing if we simplify it and go with these. So when looking for a pattern, you want to go with these numbers here. Don't quote simplify it, because then you won't be able to see the pattern. Okay, so let's go ahead and give that a shot here with e to the -6x and see if we can find a pattern. Okay, so I'm going to go ahead and make a chart. So n, and what goes next in the chart? Nth derivative, that's right. And it says Maclaurin, so this is 0, right? So the nth derivative, and then the nth derivative at 0. We want that one. Why did I? Why can't I draw a straight line here? Ugh. Okay, and then the last one would be the nth derivative at 0 divided by n factorial. Okay. So 0, 1, 2, 3. We'll just go as far as it takes until we can see a pattern. Okay, so the first one is it's just itself, so that's e to the -6x. And if you plug in a 0, what do you get?
1.
Correct, you get 1. And so you have just 1 over 0 factorial, which is 1. Okay. Okay, so now the first derivative, you take derivative of this, what do you get? You get
-6.
-6. And then if you plug a 0 into here, you get
-6.
-6. And you divide by 1 factorial, that's still going to be -6. But maybe we'll put that over 1 factorial. I'll put this over 0 factorial. Okay, now next thing is you're going to get what? You're going to get
36.
36.
36.
Okay, let's write that as -6. So the thing is that when you do this, try not to like quote simplify it and cancel stuff off. I mean, it's kind of hard to resist the urge because, you know, when you simplify stuff, that like, I think that gives your brain some dopamine, right? Simplifying things is like dopamine. And then when you don't simplify, it's like you get depressed, right? So, but it's kind of hard to resist the urge, but try to do it. Okay, what do you think the next one's gonna be? Can you see a pattern here at all?
X
What do you think the next one's gonna be without going, what's that?
-6 cubed.
Well, for sure the denominator is gonna be 3 factorial, right? So what do you think the numerator is gonna be?
-6 cubed.
-6 cubed, right? And the next one would be -6 to the 4th, right? Over 4 factorial.
Amazing.
So that's what it looks like it reads. And then, so then the terms are going to be this 1 over 0 factorial x to the 0, and then -6 over 1 factorial x. And then this is multiplied by x squared. And this one is multiplied by x cubed, and this one's multiplied by x to the 4th. And in general, we're going to have -6 to the n over n factorial x to the n, right? Okay, so let's try that. We'll try that one. Okay, I got it correct. That's for the first part. Okay, so essentially you have the series. So that's the answer right there. And what do you think the radius of convergence is?
1.
It's greater than 1, by the way. Okay, so if you do the ratio test here, what happens when you have an n factorial in the denominator?
Comes
And we'll say geometric in the numerator and n factorial in the denominator. What happens? Your series is going to converge. No matter how big this numerator is, it's going to converge. So your radius of convergence is infinity. And the ratio test would probably be the way to verify that, if you felt like it. Okay, so number 4. It says, find the Taylor series. Ooh, Taylor. Find the Taylor series centered at the given value of A. So A is -4. Assume that F has a power series rotation. Do not show that Rn is, oh good, I don't have to show that. Or maybe you wanted to show that, but we're not supposed to, so let's not. Okay. Okay, so here, this is, we make a table again. And this time we're not going to be so much space because it's just, what is it? 10, we'll write it as 10x to the -1. And then we have to plug in -4 because that's what the A is. So it's the A here. And then we got to take, let's see, the nth derivative at -4 divided by n factorial. Okay. Okay, so if we put a -4 into here, what do we get?
5 halves. -5 halves.
Okay, so like I said, don't simplify it. So it's 10 over -4. Okay. So 10 over -4. Divided by 0 factorial. Okay, now I take the derivative of this. What do you get?
-10. Is that ln?
X to the negative square. 2.
Oh.
Yeah, -2. Okay, now when you plug a -4 in, you're going to get -10 over -4
Square.
squared. Okay, and then let's go to the next one. What's the derivative here?
-20. Oh, +20. -3.
Okay, now in fact, maybe what we should do is write it as 2 times +10. Wait. X to the -3, right? So that's going to be 2 times 10 over -4 to the 3rd power Okay, now here you're dividing it by 2 factorial, right? Which is just going to take the 2 out. So let me see here. Here you divide by 1 factorial, which doesn't do anything. Negative 10 over negative 4 squared.
Oh,
And here you're dividing by 2 factorial, which will just take that 2 out. So let's just take that 2 out. And you get that. Okay, now the next one, you have a 3 coming down, right? So you got 3 times 2, but there's going to be a negative. Oh my goodness. And there's going to be x to the negative 4, right? Okay, so it's going to be negative 3 times 2 times 10 over negative 4 to the 4th. And so then when you're dividing by 3 factorial here, so that's going to take the 3 and the 2 out. So you get negative 10 over negative 4 to the 4th. Okay, so you guys see a pattern.
Yes.
Okay, so since we're expanding about negative 4, you put a negative 4 into here, and you get x minus the negative, which is x plus 4 to the n. So that's going to be your term right there. Now, what's the coefficient going to look like? Now, it's alternating, the numerator is alternating between 10 and negative 10. 10, negative 10, right? So we'll put a 10 there, and then we'll put a negative 1.
To the
Now, if
end.
you put n, then that's going to work, because when it's 0, you want it to be positive, and when it's negative, when it's odd, you want it to be negative. The odds are negative, the evens are positive. And then the denominator would be negative. Oh, dang.
Sick.
Oh, n plus 1. Well, that's not good. Okay, so actually, here's what happens. How did that happen? Wait a minute, I'm confused. Oh yeah, no, this makes sense. So this and this negative here, and all of this cancels just to negative. So you have negative 10 over 4 to the n plus 1. Okay, let's try that. Okay, so that works, and hopefully you saw a little bit of how we came up with that pattern. Anybody want to take a guess what the radius of convergence would be?
It's 4.
What'd you say?
I'm guessing it's 4.
I think it's 1/4.
It's 4,
Oh, dang it.
because this 4 to the n is in the denominator, so that helps it to converge. So with a 4 down below, it helps it to converge. If the 4 was above it, if the 4 is in the numerator, then the radius would be 1/4. Okay. Another way that you can tell in this particular problem, is this, okay? Let's see here. Okay, so we didn't need all that, right? We didn't need that. So we didn't need the 4 either. We didn't need that. Okay, here's another way you can tell with this particular problem. You have 10 over x, right? And a is -4, right? So that's -4. That's where we're expanding it about that right there. Now, this function at 0, 10 over x is undefined, right? Doesn't work. That's the only place where it's undefined, right here. And so as a result, you can't have anything that converges at, because this is undefined, then whatever series that represents this function is not going to work at this point. So the distance between there and there is 4. Okay, so that means that helps us to tell that the radius is going to be 4. The radius of convergence is going to be 4. So you will typically be able to expand out to there. Now, what complicates this is that this is actually something from complex variables. So if you have a complex number, a complex non-real number that where this doesn't work, that's closer than that one, then the radius will be smaller. But this is not the case, okay? This is not the case. So it would be the case if it was like 10 divided by x squared plus 1, where here I and negative I make the denominator 0. So the distance between whatever point you're centered at and I or negative I, that would be the radius of convergence. Okay. Okay, or you can just look at this form right here and say, well, there's a 4 to n plus 1, or you can just apply the ratio test. Okay. But here it's going to be 4.